Okay, so in this lesson, we're going to look at solving linear inequalities. We're going to particularly look at using the addition and multiplication properties of inequality. In a previous lesson, we looked at using the addition and multiplication properties of equality. So now we're going to look at an inequality. So for example, if we want to solve this inequality, suppose we had x minus 2 is greater than or equal to 7. So x minus 2 is greater than or equal to 7, and I'm going to solve this inequality. If this were an equation, you would add 2 to both sides. You would use the addition property of equality, so you would add 2 to both sides. You solve an inequality just like you would an equation. So you're going to isolate the variable. So to get the variable x by itself, you want to do the inverse operation here. So since you're subtracting 2, the opposite would be to add 2, but what you do to one side, you have to do to the other. And then you can combine like terms. So when I combine like terms, a negative 2 and a positive 2 is 0. They're opposites of each other, so you get x to be greater than or equal to 9. Now what this represents, this x is greater than or equal to 9, are the solutions to this inequality. So for example, if you go back to the original inequality, this inequality right here, if I substitute any number that's bigger than or equal to 9 into this inequality, it will make this side right here greater than or equal to 7. So for example, 10 is bigger than or equal to 9. So when I substitute 10, I get 10 minus 2 is 8, and 8 is greater than or equal to 7. Now, in the previous lesson, we talked about the equal sign here. So the equal sign indicates that 9 is also a solution because 9 is greater than or equal to 9. So since 9 is greater than or equal to 9, that means, now remember these are all equivalent inequalities, so that means that the solutions here would be a solution here. So 9 is bigger than or equal to 9, which also means that 9 minus 2, which is 7, is greater than or equal to 7. So any number greater than or equal to 9 is a solution to this inequality. Now to graph this, you're going to use what you learned in the previous lesson. So to graph this, if this is 0, and this is 8, and this is 9, you're going to put a, now remember you could use a closed circle or a bracket here, since this is an equal sign. So if you use a closed circle, you're going to put a closed circle on the 9, because you can include the 9, and you want to shade in all the solutions. So you're graphing the solution set. So there are an infinite number of solutions here. There's not just one. If this was an equation, that would just be one solution. It would be this 9. But since it's an inequality, there's an infinite number of solutions. So then you shade any number greater than or equal to 9. So any number bigger than or equal to 9 is a solution. So that's the graph. Now interval notation, since that's a closed circle, since I can include a 9, you're going to say bracket 9, comma, to infinity. Now remember, infinity, negative infinity, you're always going to use parentheses. All right, now if you want to use a bracket instead of a closed circle, so this is 0, this is 8, and this is 9, you would say bracket pointing to the right because your solutions are to the right, and you get this graph. Okay, the interval notation would be the same way. All right, so that was number 1. Okay, number 2, suppose you had 3x minus 5 is greater than 2x minus 8. All right, so 3x minus 5 is greater than 2x minus 8. So again, you want to find the solutions to this inequality. So if this was an equation, you would use the addition property of equality, the multiplication property of equality, and so forth. I'm sorry, equality. Now we are dealing with inequality, so we're going to use the addition and multiplication properties of inequality. So it's the same way as you did the equalities. So let's go ahead and bring the variables one side, constants the other side. So we're going to subtract 2x from both sides. Now what I do to one side, I'm do to the other. So I'm using the addition property of equality. And then I can combine like terms. 3x minus 2x is x. I get x minus 5 is greater than 2x minus 2x is 0. 0 and a negative 8 is a negative 8. And then adding 5 to both sides, and we do the inverse operation. So since I'm subtracting 5, the opposite is to add 5. But what you do to one side, you have to do to the other. Combine like terms, so I get x is greater than negative 3. So Remember, all these are equivalent inequalities. The solutions here are the same as the solutions here, same as the solutions here. So I found the solution. So any number bigger than -3 is a solution to the original inequality. So for example, let's just check x is greater than, check x equal 0, because 0 is bigger than -3. So let's see if x equals 0 is a solution. Let's go back to the original. So 3x minus 5 is greater than 2x minus 8. And so wherever I see wherever I see the variable x, I plug in 0. So 3 times 0 minus 5. And the question is that bigger than 2 times 0 minus 8? Well, this right here is -5. And this right here is -8. And -5 is bigger than -8, is greater than -8. So 0 is a solution. In fact, any number bigger than -3 is a solution. All right, so on your number line, though, this is 0, this is -2, this is -3. Since there's no equal sign here, which means that -3 is not a solution. -3 is not a solution. Make sure you understand that there's no equal sign. So what that means is this. If you check x equal -3, so you go to your original inequality, and where we see the variable x, you plug in -3. So 3 times -3 minus 5. And you want to see that's bigger than 2 times -3 minus 8. So 3 times -3 is a -9. A -9 and a -5 is a -14. Over here, 2 times -3 is a -6. And a -6 and a -8 is a -14. And the question is -14 greater than -14? No, it's not. -14 is equal to -14. So that's why you cannot include -3. So in that case, you're going to use an open circle, and you want all the solutions that are the real numbers that are bigger than -3. So you can go to the right, and make sure you draw your arrow. If you were to use brackets or parentheses, you would have to use parentheses here. So you'd say -3, parentheses pointing to the right. And so there's your solution. Now the interval notation, you'll say parentheses -3 comma to infinity parentheses. All right, so that was number 2. All right, now let's look at this one. Suppose we had number 3. Suppose we had 2x is less than -6. So 2x is less than -6. All right, so we got to isolate the variables, so we got to get the variable by itself. So right now the coefficient is 2. I really want this coefficient to be a 1. So since I'm multiplying x by 2, the opposite of multiplication is division. So I'm going to use the division property of inequality. So what I do to one side, I do to the other, just like I would if this was an equation. And so 2 divided by 2 is 1. 1 times x is x, so I get x is less than -3. All right. So then your solutions would be any number that's less than -3. I cannot include -3 because remember, if you check x equal -3 in the original problem, you'll see this. You'll see 2 times -3 is -6, and the question is -6 less than -6? The answer is no. -6 equals a -6, so you're going to have to use an open circle or parentheses here. This -3 is not a solution. So this is not a solution. In fact, your solutions would be any real number that's less than -3. So your graph, if this is 0, this is -2, this is -3, you'd have an open circle pointing to the left. So all the solutions pointing to the left, all the real numbers to the left of -3 is a solution. If you use parentheses instead of open circle, you'd have the parentheses pointing, make sure it looks like a parentheses though, not a bracket, pointing to the left. And then your interval notation, remember you always read a graph from left to right, so your interval notation, since this is pointing towards -infinity, you're going to say -infinity to -3. So parentheses -infinity to -3 parentheses. So that's your interval notation. Okay, so in number 3, we had solved a linear inequality by dividing both sides by positive 2. And so the next question becomes this: what happens if we multiply or divide both sides of an inequality by a negative non-zero number? So for example, we all know that negative 2 is less than, let's say, 5. That's a true statement. The statement is true. Negative 2 is less than positive 5. But what if I were to, taking that same statement right here, taking the same statement, but divide both sides, let's say, by negative 1. All right, and the question is this statement, is this still going to be a true inequality? So in other words, negative 2 divided by negative 1 is 2, and then 5 divided by negative 1 is negative 5. And so the question is that still a true statement? All right, so this right here is not a true statement, so that's not true. So the idea is this: when you divide or multiply both sides of an inequality by a negative number, 2 is not less than negative 5. That's not a true statement. What happens is that 2 is greater than a negative 5. So when you divide or multiply both sides of an inequality by a negative number, you have to reverse the inequality symbol. So reverse the inequality symbol. Okay? So for example, let's suppose we want to solve this inequality. Let's suppose we had negative 3x is greater than, let's say, 6. Negative 3x is greater than 6. All right, so to get the variable x by itself, I would right now multiplying x by negative 3. So the reverse operation is to divide both sides by negative 3. So I'm dividing both sides of this inequality by negative 3. So remember, if you divide or multiply both sides of an inequality by a negative number, you have to reverse its inequality symbol. So negative 3 divided by negative 3 is 1. 1 times x is x. So my solutions to this inequality, to the original inequality, would be any real number that's less than, you got to reverse this, so greater than becomes less than, would be less than, and then positive 6 divided by negative 3 is a negative 2. So you graph, if this is 0 and this is negative 2, I would have an open circle, and then I would graph all of the solutions, all of the real numbers that are less than negative 2. And then your your interval notation, so remember you always go from left to right, so my graph is going from negative infinity to negative 2. So parentheses negative infinity, comma, negative 2, parentheses. All right, so number 5. Okay, suppose we had negative 2x plus 5 is, let's say, greater than or equal to, let's say, negative 1. All right, so to solve this inequality, I'm going to subtract 5 from both sides. I'm using the addition property of inequality, and then I combine like terms. So I get negative 2x is greater than or equal to a negative 6. And then I've got to get the variable x by itself. So right now I'm multiplying the coefficient of x is negative 2, which means I'm multiplying x by negative 2. The opposite is to divide both sides by negative 2. So the again, I'm using the multiplication property of inequality here. And so negative 2 divided by negative 2 is 1. 1 times x is x. But remember, if you multiply divide both sides of an inequality by a negative number, you have to reverse this inequality symbol. So I get x. So the solutions would be any number, any real number that's less than or equal to, and then a negative 6 divided by negative 2 is a positive 3. So if this is 0 and this is positive 3, I would remember 3 is a solution because of the equal sign. So I'm going to put a closed circle and then pointing to the left, because I'm shading in all the real numbers less than or equal to 3, because those are solutions. And so your interval notation would be negative infinity. Remember, with infinity, negative infinity, always use parentheses. So I'm going from negative infinity all the way to 3, and then since I can include 3, that's going to be a bracket. All right, number 6. So number 6, suppose you had negative x is greater than, let's say, 0. Negative x is greater than 0. All right, so remember, we're trying to get the variable x by itself. So you got to remember that negative x right here really means the same thing as negative 1x. So I'm just rewriting this right here as negative 1 times x. All right, so to get the variable x by itself, you're going to divide both sides by negative 1. Now remember, I'm dividing both sides by a negative number, so if you divide or multiply both sides of an inequality by a negative number, you got to reverse this inequality symbol. So negative 1 divided by negative 1 is 1. 1 times x is x. So the solutions would be any number that's less than, and then 0 divided by negative 1 is 0. So this is 0 on the number line. Since 0 is not a solution, we use an open circle. And then I need to graph all the real numbers that are less than 0, so to the left. So those are your solutions. And then your interval notation would be negative infinity, comma, to 0, with parentheses. Since this is an open circle, I cannot, 0 is not a solution, so you can use parentheses. Okay, number 7. All right, number 7, suppose you had negative 8 is less than x plus 7. Negative 8 is less than x plus 7. All right, so the variable here is on the right-hand side, but it doesn't matter whether you bring the variables to the left or the right. It does not matter. You just got to be careful, though, when solving this inequality, when graphing the inequality, when graphing the solutions. All right, so let's go ahead and subtract 7 from both sides. I'm using the addition property of inequality. And then negative 8 and a negative 7 is a negative 15 is less than, and the negative 7 and positive 7 is 0 is less than x. All right, now remember, you got to be careful. So what this means is that negative 15 is less than, and remember, these are your solutions. So negative 15 is less than any real number. That's your solution. Any solution. So negative 15 is the smallest. So that's what that means. Negative 15 is the least. So when you graph this, what that means then, if negative 15 is the smallest, because remember less than, is the smallest in any other solution, then what that means is that x is greater than negative 15. So they mean the same thing. So these two mean the same thing. So, and if you understand that negative 15 less than x means that negative 15 is the smallest solution, although you can't use it because there's no equal sign. But it also means it's equivalent to meaning that x is, your solutions are greater than negative 15. So if negative 15 is the smallest, then that means your solutions are bigger than negative 15. Okay, so this is 0. This is negative 15. Since there's no equal sign, use an open circle and then pointing to the right. So the point here being this, in all the examples we've done, the variable was always on the left-hand side. So it's easy to graph, because if less than, your solutions would be any number less than negative 2, so you graph to the left. Your solutions would be any number less than or equal to 3, so you graph to the left. Your solutions would be any number less than 0, you graph to the left. Here, let's see, here your solutions would be any number greater than negative 3, so you graph to the right, because greater than you go to the right. Here, though, you have to be careful. Don't overgeneralize this. See, be careful. Don't put negative 15 on the number line and see the word less than, or see the symbol less than, and then graph to the left. You got to remember this, where the variable is located. The variable here is located on the right-hand side. So that means that negative 15 is the smallest, is less than, is the smallest than all the other solutions. So negative 15 is the smallest. So your solutions are going to be to the right-hand side. So sometimes it's helpful if you rewrite this inequality where the variable's on the left-hand side. So if negative 15 is less than x, that means that x is greater than negative 15. That means that your solutions are greater than negative 15. All right, now the interval notation here would be negative 15 parentheses, since I can't use negative 15, all the way to infinity with parentheses. All right, number 8. Suppose you had 7 times x plus 1 is minus 6x is greater than or equal to negative 4. So 7 times x plus 1 minus 6x is greater than or equal to negative 4. Now, before we go on, the directions also will ask you to write the solution set in set notation. So remember this is your graph. This is your interval notation for your solutions. So this is the graph of the solution. This is the interval notation for your solution. Now here's set notation. All right, so listen to this carefully when you write your set notation. So set notation, you're going to write as a set. So you're going to use that open brace to use braces. So it'd be the set of, and you always use your variable. The variable here is x. If this was y, you'd say y, whatever your variable is. So you say the set of x's such that. So this symbol right here means such that. Such that. So the set of x's such that x is, and you just write your inequality. So such that x is greater than negative 15, and then close brace. All right. So over here, you're going to do the same thing. You're going to graph. You're going to put the interval notation, and you're going to do set notation. All right. So over here to solve this, you're going to first of all use the distributive property. So 7x plus 7 minus 6x is greater than or equal to negative 4. Then combine like terms. 7x and minus 6x is x, so x plus 7 is greater than or equal to negative 4. Then subtract 7 from both sides, combine like terms. I get x is greater than or equal to negative 11. So your solutions to this original inequality would be any real number that's greater than or equal to negative 11. So on your number line, if this is 0 and this is negative 11, it will be a bracket or a closed circle, and then graphing to the right. So you want to graph all the real numbers that are greater than or equal to negative 11. So again, if you were to use a bracket, you'd have to say this, bracket pointing to the right, like this. Okay, interval notation, you may read a graph from left to right. So you're going to start at negative 11 all the way to infinity. So bracket, negative 11, comma, infinity, parentheses. Remember, infinity and negative infinity, always use parentheses. Set notation, this is set notation. So you can say the set of x's such that x is greater than negative 11, greater than or equal to negative 11, and then close your brace. So make sure you use braces. So remember, set of x's such that x, and you just write your inequality, such that x is greater than or equal to negative 11. So that's your solution set. Okay, number 9. All right, number 9, suppose we had 5x minus 7x. 5x minus 7x is less than or equal to x plus 2. So 5x minus 7x is less than or equal to x plus 2. All right, so combine like terms first. 5x minus 7x is a negative 2x is less than or equal to x plus 2. All right, so let's bring the variables to the left-hand side. So I'm going to subtract x from both sides. So what I do to one side, I do to the other. So a negative 2x and a negative 1x, remember that's understood to be a 1 right here, negative 1. That's a coefficient. So that's a negative 3x is less than or equal to, and then negative x plus x is 0 is less than 2. And then dividing both sides by negative 3. Now remember, I'm dividing or multiplying both sides of an inequality by a negative number, so I've got to reverse the symbol. So I get negative 3 divided by negative 3 is 1. 1 times x is x. So I get x. So the solution would be any real number that's greater than or equal to a negative 2/3. So any real number that's greater than or equal to a negative 2/3. And so the number line, if this is 0, this is negative 1, this is negative 2, negative 2/3 is between 0 and negative 1 and closer to negative 1. So remember, negative 2/3 is negative 0.66666. So let's say it's about here. Let's say right here. So that's negative 2/3. So since I can include negative 2/3, since negative 2/3 is also a solution because of the equal sign, I'm going to put a closed circle or a bracket, does not matter. Closed circle, and I'm graphing all the real numbers that are to the right side, to the right, because greater than or equal to the right of negative 2/3. So that's what the graph looks like. And then Your interval notation, you're going to say bracket negative 2/3, comma, to infinity. And then set notation, you're going to say the set of x's such that, so remember it's got to look like this, set of x's such that, and then you just write your inequality right here. So such that x is greater than or equal to negative 2/3. And then make sure you close your brace. All right, number 10. Okay, number 10, suppose we had this. All right, number 10, let's say we had 3 times x minus 5 is less than 2 times 2x, that's 2x, minus 1. So 3 times x minus 5 is less than 2 times 2x minus 1. Okay, so first thing you do is use the distributive property on both sides. So I get 3x minus 15 is less than, and then that's 2 times 2x is 4x, and then 2 times negative 1 is a negative 2. Okay, it does not matter which side you bring the variables on, but remember, if you bring the variables on the right-hand side, you got to remember how to rewrite this. Don't mess up with the graph. All right, so let's bring the variables to the left, and then we'll also do another one where we bring it to the right. So I'm going to subtract 4x from both sides. And so combined like terms, 3x minus 4x is a negative x. Minus 15 is less than, and then that's 0. 4x minus 4x is 0. And you're left with negative 2. Adding 15 to both sides, and then combine like terms, I get negative x is less than, and then that is 13. All right, now remember you're trying to get the variable x by itself, so you don't quite have it. This is negative 1x. So remember that's negative 1x. And so you have to divide both sides by negative 1. So remember that you got to do the inverse operation. So right now you're multiplying x by negative 1. The opposite is to divide by negative 1. But remember, you're dividing or multiplying both sides of an inequality by negative numbers, so you got to reverse the symbol. So negative 1 divided by negative 1 is 1. 1 times x is x. So your solutions would be any real number that is greater than a negative 13. Those are your solutions. So less than becomes negative, less than becomes greater than. And so your graph, this is 0 and this is negative 13. So open circle or parentheses on negative 13. Let's use parentheses this time. And you're going to the right because you want to graph all the real numbers that are greater than negative 13. So don't forget to draw your arrow though. So you shade it in, draw your arrow. And then your interval notation, you can say negative 13 parentheses, comma, all the way to infinity, parentheses. Set notation, you're going to say the set of x's such that, and then you rewrite your inequality such that x is greater than negative 13, and then close brace. Okay. So that was number 10. All right, so the next lesson we'll do more problems like this, but this first set should help you understand solving inequalities, linear inequalities. Now be careful when you divide by a negative number though. So when you divide by a negative number, remember you got to reverse the inequality symbol. So when you divide or multiply both sides of an inequality by a negative number, you got to reverse this inequality symbol. Okay, so that takes care of this part of the lesson.